In our last lesson, we learned about the Rutherford model of the atom, but his model was quickly adjusted by several new developments. One man, Henry Moseley, used X-rays to probe the nucleus of the atom. These X-ray emissions suggested that the positive charge of the nucleus increased by one whole number for each ordered element. His work led to the reorganization of the periodic table by what was called the atomic number, instead of the molar mass as it had been previously. And as you'll learn more about today, the atomic number has to do with the number of protons. So when he was seeing the positive charge go up by one, he realized that these positive charges inside of the atom were actually what was leading to the organization of the periodic table, not the mass of the element. Another scientist, James Chadwick, discovered the existence of a neutral subatomic particle. So there were the positive protons, the negative electrons, and he discovered there was also this additional particle called the neutral neutron. So his discovery explained why the nucleus of the atom was so much larger than what the mass of the protons alone could explain. So he realized that the mass of an atom was mostly due to the mass of the neutrons plus the protons. The addition of the neutral neutron to the model of the atom actually happened much later than the discovery of the electrons and protons. It was a lot more difficult to detect the neutron because it didn't have a charge. But once they did, and another important fact that is reflected in the models of the atom we're going to study is that neutrons and protons are much, much bigger than electrons, so they are the two subatomic particles that contribute the most to the mass of the atom. The electrons are so small that they don't affect the mass much. It would be like saying that if I plucked a hair off the top of your head, it wouldn't change your weight. Yeah, I pulled something off, but it's so small you don't even notice. That's how electrons are in the atom. One of the most significant changes to the model of the atom that happened next was the creation of the Bohr's model of the atom. Bohr realized that Rutherford's model couldn't be totally correct because if it was, it had a problem. It didn't explain a way that would keep electrons from spiraling into the nucleus of the atom and destroying the atom. So Rutherford's model was not stable. There was also some data that Rutherford's model didn't explain, and it's these line emission spectra. We will look at them in class as well, but scientists at this time knew that if you looked at a sample of an element and you either ran electricity through it or you burned it, that you could generate these spectra. These kind of like a rainbow, but it wasn't a complete rainbow. It only showed very specific colors like these pictures show here. So, for example, if you look at hydrogen, you're not seeing all the colors of the rainbow. When hydrogen is excited by some means like electricity, you see some purple, you see this one line of teal, and you see this one line of red. They also understood that light is a form of energy. A different colored light indicates different amounts of energy. So Bohr wanted to explain these line spectra in the model of the atom, and he knew that Rutherford's model didn't cut it. It didn't explain these line spectra. So when Bohr modified the atom, he was attempting to explain why these line spectra happened. As I kind of said on the previous slide, scientists did understand that the light of different colors represented different amounts of energy. So red would have the lowest amount of energy, and purple would represent a higher amount of energy. So there's different colors represent different amounts of energy. This was the basis for Bohr modifying the model of the atom. So Bohr created a model of the atom which explained these emission spectra, or at least explained the spectrum for hydrogen. He said electrons reside in energy levels, not just individual orbits around the nucleus, but in specific energy levels. He went on to say that these energy levels are not evenly spaced. So it's not like the rungs of the ladder. The first energy level and the second energy level and the third energy level have different space between them. So they require different amounts of energy. He said that when electrons jump between these energy levels, if you give them energy by running electricity through them, by putting them in fire, both which I will demonstrate for you in class, when they get energy, the electrons jump up to higher energy levels because they're energized. They've got more energy. But eventually they will drop back down to the lower energy level they came from. And when they drop back down, they release light with different amounts of energy related to the size of the jump that they made and different colors as a result. So I would definitely, if you're taking notes by hand, sketch this model of the atom. Bohr's model still had the nucleus that Rutherford had proposed, and he said the nucleus was positively charged. The nucleus is where you would find the protons, and eventually when they were discovered, the neutrons. So his nucleus was very similar to the nucleus proposed by Rutherford. But the new part of Bohr's model was the addition of these energy levels in that cloud of electrons outside of the nucleus. So he had the first shell of electrons, which could hold up to 2 electrons. The second ring, or the second energy level, could hold up to 8 electrons. The third energy level could hold up to 18 electrons. So Bohr's addition was these energy levels, but he kept the electrons J.J. Thomson had discovered. He kept the nucleus that Rutherford had proposed. He just added his ideas on top of those. We're going to stop the notes here today. You guys are going to have the chance to work with your group on a POGL, and that POGL will help you learn a little bit more about Bohr's model of the atom.